Welcome. This video is going to show how to download, install, and run SimTwo, a powerful, easy to use, and simple robot simulator software. All the links shown in this video are going to be in the description below. There is a tutorial in the GitHub for getting started, line follower, and maze follower. Also, if you're using an Apple computer, you're going to need to install a virtual machine. For example, you can use this one here. Let's start going back to our page and downloading our software. Double-click on SimTwo.zip and install this to your computer. Now you run your file to unzip the folder, your files, and extract to the folder you just created. Let's close this. Go into your folder. If you notice, this exe file was developed in 2015. There's a newer version that you can find in this link. So you go here and download, direct the download, and save that to the same location and install the software. So we can close this, and close this. Now looking at the folder, we have two exe files. Delete the one that was developed 2015. And now we are ready to run the latest ingredient. Double click and SimTwo 2018 exe file. Now we can see that's running this script. The default script is running here, and there are 6 pages that compose part of our software simulation. So there are different pages. So the first page you're gonna take a look is this one here. Is the scene visual. The visual scene is where we can see the track, the robots, and the robot running. Any change made in the other pages, gonna be able to see here after you rebuild the program. Now we're gonna see the next page. It is the XML scene edit. That's the editor that you're gonna be able to see the XML file for all the objects and the scene that you selected. So one important thing here, if you go in the scene here and change the scene, for example, to a line follower and hit OK, your scene is gonna change, and also your XML files. Now we have the AGV, XML, and the track. If I go back to my, remember always we have to rebuild after any change in one of the 5 pages to be able to see in this page. So if you go back here and change back to the default and hit OK, now you can see 5 tabs in your XML scene editor. 1, 2, 3, 4, 5. But if I change my scene from the default to a line follower, you're going to be able to see only 2, because that's our vehicle, that's our track. The next page I want to call attention to is similar to Excel. We have variables where you can have the default values, but also we can modify the default values. We can put the AGV in a manual mode, or you can run the script. That's the default script. So if you see here, the AGV is running following that script that is written at the code control. That's a page we're gonna see next. So the page control has your code in Pascal to control this AGV in top of the line. But also, another page that has values that can modify your performance on top of this line is the configuration page. You're gonna see that after your code control. But basically here, we can stop our script. And for example, we're gonna keep running the script for a second here and put in manual stop again. these two coordinates here, the X and Y, if I hit the go to, the AGV go to my home position. That is my home position for the given default script. But another thing you have to pay attention here, this is my falling error. So I have a set point and I am 0.9 above my set point, and some point are gonna be minus under my set point. So this is gonna keep me track how my performance is gonna be. Right now I under my set point where it's supposed to be, and sometimes I'm gonna be above my set point. And I'm trying to track the line most perfect possible, and as long as my falling error is small, that my control is being optimized. So this is similar to Excel. You see the variable values, you can see the line sensor simulation values, and we can, based on that, we can determine what kind of gain we need to improve, what kind of code we need to improve. So if you're looking at in the code itself, that we're gonna see here, the next step is the code editor. So this in Pascal, and have here your subroutines based on the number of robots you have. You can have more than one robot, how many sensors line you have in each robot. You can have up to 6. You can define how you want to control your robot. So all subroutines is defined here. And here you control the code that run your robots in your scene. Could be a line follower, could be a quadcopter, could be the default scene. So it's important that you see the code and learn here how to change to what you want. And after you see this, the code editor in Pascal, we're gonna see the next line, the next tab, that's a configuration. The configuration tab has page has 5 tabs. The control tab, you can see your position, your AGV position, the X, Y, and your delta. So you can see here your actual position, your absolute position right here. You can see your global, see your photo lines for your 3 photo eyes. You have 3 photo eyes, and show which one. For example, this is the middle, it's always on, and the left and right, they are keep going off and on because we are now deviating a little bit to the left, deviating a little bit to the right, but the middle one, you always see that's on, so always on the top of the line. And then you can see the robots with the PIDs. You can change the PIDs here and see if your falling error gonna reduce or not. Then again, you can see the left axis, the right axis, and you can see your absolute position right here. Then the graphics itself, you can change some settings from the graphic. You can add some grids, you can put some fog to your scene, you can change itself based on the graphics tab from the configuration page. The debug tab is important to see what is your PID looks like. Right now I have 1, 0, and 0. And I can see that my PID speed is running at 10 milliseconds. So I see that I'm running the X0, this is the left axis. I'm running a PID for the speed loop, not for the position loop or for the torque loop, but I'm running for the speed loop. And that PID, I have 1 for proportional and 0s for differential integral gains. And I can see here my gear. That's important to know and compare between the right X and the left X and see what kind of behavior I'm getting from my falling error. Then the physics here for the AGV, I can change parameters and set. Also, the I/O tab is very important because here I can be connecting to my simulator, my PLC, my PC, or I can be also connected to another machine and send a Modbus test. I can go here, override it, and force some output coils from this program that's gonna be able to trigger another subroutine in another simulator in the same PC, or even a piece of hardware outside here. But also I can override my inputs. If I have a bit 7, 6, 4, 2, and 0 in my code, I can force it to get different behavior because my code is going to be looking to the inputs right here. And those inputs I can be able to override it, or I can let a third-party device write that based into my connection here. I can put my port here, I can change my port, I can connect and disconnect. So it's very useful, this configuration page. And lastly, is the chart. The chart page is basically to see your plotting. You can go here and do check your state, X, Y, and Z. I can go here, my left axis, my position, my speed, my torque, my current, my voltage. I can see that, or my power. A lot of things that you can see. You can see your position reference in your position reference. And then, for example, you can calculate your falling error based on your motor speed and your speed reference. So the difference is gonna be your falling error for the speed. And here to position reference and motor position, gonna give you the difference between your reference and your actual position. So you can do that for the left axis and right axis. So it's important to use also all the resources in your tab. I hope you enjoyed this, and I recommend you that you follow the tutorial that you can find in the GitHub page, and I hope you enjoyed the video.